and I'm the CEO of the company called MIDEX GmbH. We are a small engineering company in Vienna. And my background is environmental studies and renewable energy. So coming from that background, in the last couple of years, I had the pleasure to work with DSO and TSO companies. Actually, I also worked for the Austrian TSO company, and I was always very much attracted to the topic of energy efficiency, new technologies, and what we can do with all the energy transported through our natural gas grids and how we can make use of them actually. So my topic today is technology called turbo expanders, or you can call it also expansion turbines. And for all of you who are not so familiar with technical, let's say, wordings in the natural gas grid, you have to consider that on the value chain of natural gas from upstream, midstream, downstream, we have gas compressors which are compressing the gas and sending it through the pipelines to achieve security supply and heat up houses. Well, we need a lot of energy for running those compressors or gas turbines, and we then in the pressure reduction stations actually we destroy this energy. We produce friction, and as a result we have heat going to the environment and noise. Well, with technology I want to present today, we can actually recuperate this energy and kind of electrify our natural gas grids and make use of this energy for example, gas preheating or powering up our remote gas stations. And this technology is, let's say, at least here in Central Europe and the European Union, is now, let's say, having a new boom area. It's a lot of projects popped up, and a lot of countries try to implement this technology. We will start with a small presentation based on turbo expanders, which can be used in DSO stations. So we talk about downstream gas regulating stations from pressures, let's say 40 bars down to 22 millibars. And it's my great pleasure to be here together with my colleague also from Italy. And his name is Emanuele. And he will start with a short introduction on how he and his company make sure that this energy can be recuperated in the natural gas grid systems. And actually, he just also received at the COP28 a big award, which I'm very proud of. And please, Emanuele, introduce yourself. The stage is yours.
Thank you, Andrej, and thank you very much, and nice to meet you all. My name is Emanuele Guglielmino, and I'm the CEO of a company called Advanced Microturbines. We are based in the city of Genoa in Italy, and our core business is really energy efficiency. So I will now show you a few slides with some real case applications of what we do, so that you can appreciate how these technologies could be applied in your applications. So let me share the screen. Okay. Now you should Okay, let me just swap.
Yes, now it's perfect. So please go on.
Okay. Okay, so a brief mention to our company, which was born fairly recently in 2013. We won a national award in Italy when it was founded, and we spent some time in the United States, in Silicon Valley. Then we moved back to Europe, where since 2016, we made our very first pilot installation of microturbines. Since then, we moved on. So basically, we have two types of products: a very tiny and compact turbine, which, as you can see, is coin-sized. You can see the euro coin there. And a larger one, a turbo expander, which is doing the same type of job, but on a larger scale and with different application. As I said, our solution has been recently awarded at COP28 as one of the 39 solutions recognized by COP as energy transition change makers. So we have actually not just two turbines, but a family of turbines which are used both for gas and for water. And we have sold our technology to the main players in Italy and other European countries. You might recognize here Snam, the transmission operator in Italy, Italgas, which is one of the main distributor, and international companies like Emerson and Honeywell. And so what is the concept? The concept is simply exploiting the pressure drops you have in a pipeline. In the moment you have a pressure drop, the turbine is basically a device which, in front of a pressure drop, starts rotating and creating electricity basically for free. So let's see in a simple animation the concept. This is your system from one source to tank, where you have a gas flow. And the idea is creating a small bypass, so you don't touch the existing line, you simply make a bypass. And you can, in this way, feed an electronic unit, which in turn is providing electricity off-grid, so in the middle of the mountains, in an area where you don't have electricity, to feed IoT and digital sensors to enable digitalization, so smart monitoring of the gas network. And this solution is indeed more reliable than things based on solar panels, which in areas where there is no human presence are at a very risk of theft, of damage, vandalism, snow, and whatever. So let's see some quick example. This is a physical application, and on your left side, you can see some example of digital instruments which can be fed in remote areas. So you can see sensors, actuators, flow meter, router, and any other devices. And this one, and okay, these are the details. Here we go into technicalities, and this is basically an application with Snam gas operator. So this is a skid we mounted on an existing line. This is another application with Italgas. There was an existing skid, and you see in the red circle we installed the turbine. So you can see it's very flexible. And this is another one using a gas chromatograph, a special device which measures the different type of gases. So this is very common now with the use of biogas. And our solution has been also recognized by Italgas as an enabling technology for feeding the second stage pressure reduction station. So this is an analysis from a customer, and based on installation, we could find out that the return on investment is just 3.5 years because of enabling smart digital action, so reducing basically the number of field intervention in remote areas. So this is the small turbine, but we have also a larger one, which is doing the same type of job, but is larger, basically. And this is applicable in city gates, so wherever you have an interface from transmission to distribution, where you have larger flow, so order of 5,000 square cubic meter, and you can have not just watts, like in the previous case, but you can have kilowatts. So what can you do with this energy? You can use for different uses, but the most meaningful one are feeding heat pump and feeding electrolyzers. Now, to give you a more physical idea of what 50 kilowatt means, if you want to have it with a solar panel, you will need a surface as big as a football pitch. So you can see that this solution is very has a very high energy density. And on top, you can control your energy as you wish, because you can control the gas flow, wherever solar is random. So we don't really just provide the turbine, but it's a full architecture with an inverter panel and the control panel and other components. You can see here more in details the different parts, the inverter, the turbo expanders, and other ancillary components. And this is an installation we are currently doing. This is in Czech Republic. We retrofit this station, and these are the 2 turbo expanders ready to be shipped. Now, what is the real advantage? Basically, we shift from the old classical system of preheating and decompressing the gas, which is based on a pressure regulator and the gas boiler. The gas boiler is producing CO2, and on top you burn really money, because you need to take some of the gas you could sell to the end user, and you just waste it to preheat the gas. You can do this job with a turbo expander, which is also reducing the pressure. And with the electricity, you feed the heat pump. The heat pump is heating the gas as well, but you don't have CO2 emission, you don't have any burning of gas, and instead of wasting energy in a valve, you recover energy in a turbo expander. More in detail, this is the architecture. You have in the middle heat exchanger, which takes this job of preheating the gas. And you can also work out how much CO2 you save based on the local grid production. These are available data from websites, and you can work out, based on the energy production of the turbo expander, how much CO2 you can save. Now, saving CO2 is good for the environment, but it's also good for your wallet, because now in Europe, it's getting more and more popular, the carbon tax. And as far as I know, it's in average now CO2 is accounted in financial predictions as 60 euros per ton. So you don't only produce electricity, but you avoid CO2, which is another source of revenue. You can also apply this system to, let's say, more far-fetching solution, which is using the electricity to feed an electrolyzer to produce what I call green hydrogen. So this is a potential application as well. And on top, again, delving into environmental issues, if you look at the life cycle assessment, so the impact from the mine, when you mine the steel, the material, to grave when you dispose it, and you compare to solar panel, you can see that it's more efficient in terms of CO2 over the life cycle. In this study we did, the European Commission, we calculated 170 tons of CO2 considering 150 kilowatt production. Of course, this is very important for large companies, for the corporate social responsibility, also in the light of the new European directive called ESG, Environmental and Governance. you can do really more accurate financial calculations. So starting from the physical data, you can calculate numerically your return on investment. This is an example. And you can see that the return on investment is about 3 years. So this figure is very important to do financial prediction on the investment. You can also work out easily the net present value for just one site or for multiple sites. And we can also support doing this type of simulation to make predictions of a campaign of several installations. And then we have also water microturbines, which is not really your application, but the concept is actually the same. You have a bypass, you have a turbine like this one, and we have a different application. We have installed our units in Italy, in different parts, in Greece, in Switzerland, and many other countries. So this is it, and this is a brief summary of our technology that, as you can see, is very flexible and has been already installed with several customers with different type and backgrounds, and can be quantitatively, we can now assess accurately both from an energetic and energy efficiency viewpoint and also from a financial viewpoint, which is the return on the investment of this application, which, as you can see, it's in the order of maximum 3 years, more or less, which is a very good one, considering it is a machine, and usually machines have much longer time. So thanks for your attention, and thank you, Andrej, for the opportunity of talking today, and I pass on to you to go on with the event.
Emanuele, thank you very much. Please stay with us half an hour more to accept maybe questions which are going to be passed. And if you can just stop sharing your screen, and then then we will switch to screen to Vienna.
Yeah.
And actually, congratulations for award on COP28, and actually I'm really happy that we have really timely presentation, up to date with the new technology, and actually very useful, and then bringing a lot of benefits. So now we will pass to Andrej here, and I will try to share screen from here. Let's see.
Full screen.
Please help me.
I will try. Excuses for the small technical issue. We will have it done within a minute. Okay, but I think we can also keep it like this.
Apologies for that. So far, WebEx should be smooth and so on, but unfortunately it's not. But nevertheless, Andrej will start with presentation.
Okay, thank you, Carolina. So as we heard from Emanuele from Italy, we can use this technology for recuperating the energy in electricity, so turn it from waste pressure in pressure reduction stations to electricity, which is then feed it into the grid or used for any devices powered by electricity in the stations. And normally this is very interesting because the natural gas regulation stations or measurement stations are in a location where sometimes it's very difficult to have a substation or to organize power supply. So coming from smaller units, I also wanted to show what is the state of the art in terms of technology in the US. And I will give you a very short overview on a product from the company called Sapphire Technology from California. And it is quite similar to what we just saw from Emanuele, but the units are quite bigger. So those units are typically used in mid and upstream. So with this technology, you can make sure that along your gas value chain, you can make use of this technology in any point of the value chain. I will focus on pressure reduction stations because I'm sure in your networks, in your countries, you have hundreds of those. And give a short example from Japan and the US, and give you maybe also some ideas what will happen in the future addressing the topic of hydrogen. Next slide, please. Thank you. So very short background on Sapphire Technologies. Sapphire Technologies is a spin-off of Calnetics, and the company is famous for active magnetic bearings, and they use this technology in gas turbines, which are maybe also installed in one of your countries in some gas turbines which are used in the compressor stations to compress the gas and ship it all through the pipeline to the end users. The product I want to present today is the free spin. It's a turbo expander, and it has active magnetic bearings. So it's a quite new technology, and it's a very sophisticated product, but very robust and compact. So those units are much bigger than the units we saw before because they address, let's say, different stations, different flow ratio, different pressure ratios. So when you see it's like turbine gas meter, it's quite compact. You put it into the gas pipeline with the flanges, and at the beginning you see the turbine wheel, and the long thing in the back is the rotor and the stator, which is then connected. When you see on the other side, on the bottom side, you see the connectors for the cables, which are then connected to a cabinet, and the turbine is working like a pressure reduction valve, but in terms of destroying the energy, it is sending the energy to the cabinet and then to a, for example, substation. Next slide, please. So in any case, you will need 3 system components, which is the turbo expander or expansion turbine by itself, a cabinet where you make sure that you operate the turbine, and a resistor for security reasons, so that you can make sure that once the electricity is not going to the grid, that you have no failures or emergency situations. And I think the most interesting application for this technology is actually the typical natural gas pressure reduction station. Here we can see the value chain as just mentioned, and you can see from the natural gas wellhead, from the natural gas field, until to the gas storage facilities or LNG regasification plants. You can find application where you could make use of this great technology along the entire gas value chain. Next slide, please. And if you think about the global potential of this energy, we talk about hundreds of gigawatts hours, which we can recuperate in all those gas reduction stations all over the globe. And only for Austria, where we are based right now, we talk, for example, about potential of more than 100 megawatts hour for the turbo expansion valves in pressure reduction stations, in DSO stations in Austria. So Austria is a very small country, and imagine what is the overall potential in your country, for example. Next slide, please. This is a typical pressure reduction station, maybe not in your country, but in the US. And we see two lines with two regulators, and they're called Joule-Thomson valves in the US. Here in Europe, we used to call them regulators, and some safety devices before and after. So once you install a turbo expander, or as we also saw it in the slides from Emanuele from Italy, put them in parallel, in series. So you normally make a bypass. Next slide, please. And then you see that you can connect these turbo expanders to the cabinet. And here we also see some instrumentation like a meter and pressure and temperature transmitters for online and accurate operation of the turbo expander. Next slide, please. Next one. As I mentioned in the beginning, I want to show you two applications from Japan and the US. This one is a LNG terminal in Japan. And next slide, please. You will see right now where the components are installed, and they make use of the existing pressure drop, and the electricity is then fed into the grid. You see here a 300 and a 125 kilowatt unit. So you see that those units are quite massive and big. Next slide, please. Yeah, here you can see the connectors, which are also quite massive. Yeah. Next slide, please. These are the cabinets and the brake resistors. So we talked about the LNG terminals. We talked about the midstream applications in gas TSO and DSO systems, about upstream. So once you have some gas fields, you want to make sure that you have some compressors there and coolers, so you can find some pressure drop in those applications and use the electricity for down system, because you must make sure that you supply those refineries and upstream process units with a lot of electricity. One very interesting application is also hydrogen. We see that big hydrogen projects coming up in Europe, and we will see hopefully a big hydrogen infrastructure with 100% hydrogen. And it would be also interesting to see that in future this application working with 100% hydrogen. Next slide, please. This project is a natural gas pipeline in the Rocky Mountain area in the USA, and Sapphire would make sure that they deliver 72 units. And the application here is very interesting because here, this project, we don't feed into the grid the electricity because those stations are in very remote areas, as you can imagine. So what is the application after those turbo expanders? Next slide, please. You can see here in those containers, these are actually remote data centers. So as we are all aware that we will need more and more data centers for AI and other applications, we can also think about using the electricity, the remote electricity, for decentral remote data centers. This is the way those turbo expanders are installed in the US. It's a little bit different than we do it in Europe, but I think it's quite interesting to see what is going on over the Big Lake. Yes, these are the cabinets. Next slide, please. And here you actually see those units. They are also quite massive. You can imagine they are almost 2.5 meter long and 1.5 meter diameter. So you actually can think of 3 components: the resistors, the cabinet, and the turbo expander, and you can more or less easily install them in your existing gas infrastructure. So we don't talk about greenfield projects here. You can use it in your brown existing installation and make sure to increase your energy efficiency, electrify your gas system, make sure that you have the electricity on your stations, or feed into the grid. Next slide, please. And a very good point is feeding into the grid. In the European Union, we have the second and third package telling us something about unbundling. So as an energy transport company, we're not allowed to produce energy. And so one of those big players in Europe, they are working now on a project so that we use the electricity coming from a turbo expander for powering an electrolyzer, and the hydrogen produced by the electrolyzer is then injected back into the grid. So on the one hand, we can make sure that we decarbonize our gas grids, and on the other side, we can make sure that we increase the hydrogen content in our natural gas systems, for the gas system.
All this gas.
Next slide, please. Yeah, Sapphire is, as I mentioned, also planning to present the 100% hydrogen version because of the physics and the density of hydrogen as a molecule. They are still working because it will actually need more gas to achieve similar efficiencies in terms of electrical output. Yes, and I have some more information. Maybe next slide, please. One of the typical stations for those big turbo expanders, we talk about flow rates above 7,500 cubic meter hours or even above 10,000 cubic meter hours, and the typical pressure rate of 1 to 2 or 1 to 3. So we want to, for example, look into stations where you have inlet pressure around 20 bar and then outlet pressure around 10 bar. Also, the inlet temperature is very important. So the higher the inlet temperature, the more efficient is the turbo expander. In some occasions, we even have to preheat additionally or to make use of industrial off-heat. For example, in some countries, we see that big industrial factories are connected to the high pressure natural gas grid, and we can find some off-heat or waste heat from those industrial sites and use them in the gas station, in the gas reduction station, for higher and more efficient turbo expander, so the electrical output will be higher. Yeah. Next slide, please. These are some clients which can be mentioned, and this is now the end of my presentation, but I'm sure that there will be some questions on this topic, so I want to give now the stage to you, and I'm looking forward from some feedback. What do you think about this technology, and what is the situation in your country? So are there any questions? Please raise them now, or you can also write into the chat, and I will try to give you answers right now or answer later.
So thank you, Andrej, and thank to Emanuele before. So we are opening the floor for questions. We already got 2 questions, and they're not so technical, but more in policy and regulatory framework. But nevertheless, we have a question from Despa. So shall I read it, or maybe Agnes can unmute himself and ask the question directly if you want.
Yes, of course.
Yes, please.
Thank you so much for the very insightful presentations. My question is about the hydrogen production from such installations. And I was wondering what will be the classification of such hydrogen. It will be like low carbon, clean, or what? Because it's energy that otherwise will be wasted. But in order to inject and make it available to the market, what probably will be the classification of such hydrogen? This is my question. Thank you.
I would like that we can answer those questions, but here we were focused actually more on technology and energy efficiency as such. So I really don't have the answer. What would be then production of hydrogen using energy, improving energy efficiency and using the waste pressure and by-side electricity production. So for that, I think we have to also wait to approval of the entire new gas package. But let's put it that way. Question will not be forgotten. So we are going to answer it soon. I mean, maybe in the next webinar, or actually publishing maybe materials together with presentations and the recorded webinar. The other question is also coming somehow from the same area, and I would say, yeah, from Wojciech. So if you like to ask your question directly, please unmute yourself and do so.
Yes, thank you very much. Thank you for your interesting presentation about the turbo expanders. The concept of effective use of pressure reduction to produce electricity seems to be correct and well known. But and I have a question because do energy regulatory offices accept this concept to produce electricity by the gas DSOs? Because I know that regulatory authorities point out that DSOs are limited to operational activities related to the gas, not to electricity. So this is my question. Thank you very much.
Can I answer?
Yes, yes, please.
Yeah. We have the same issue in our installations. This really depends on the legal status of the DSO, but what we found out that in any case, the easiest and simplest way is to use this electricity for internal use. So if you use for a heat pump, you don't sell anything to the grid. And in this case, you don't really have to have any special permission to use it. And since there is a lot of work to do preheat the gas, you need quite some energy, you can happily use your electricity for internal use in most cases. And if you have something not exceeding, you can store in a battery or whatever other form of storage.
Okay, thank you very much. Thank you.
Thank you very much for this question. I will also try to give you some part of the answer. So in Austria, for example, we see the situation that in the past, it was before unbundling, we had one energy company, and for example, natural gas for preheating in gas reduction station was just used out of the network. Nowadays, this gas and also the electricity has to be acquired by the open market. And so we see that TSO companies, for example, in Austria, they build, for example, PV plants. But this electricity coming from own PV plants is only allowed to be used in their energy, we call it budget. So it can be used for own consumption, and as you have to make sure that it covers your own consumption and that you're not producing more than you consume. And my experience that is the energy consumption and the electrical consumption of DSO and TSO companies is quite big. So I think there is a certain delta in this budget which we can make use of, and we can fill this delta with this technology. I hope this was some part of answer to your question.
Thank you.
So, I mean, with this webinar, actually, we wanted to start from technology point of view and solutions which will be kind of needed, and they are already in place or can be applied and so on. Kind of between technology and real operation until waiting that the new gas package is approved. But I see that Mr. Kolesnik, Deputy Minister from Ukraine, raised hands. So please, Mikola, put your question.
Carolina, thanks, Lily. Just to clarify the answer regarding the last one, because frankly speaking, all that gas turbine and gas pump, the same as turbo detenters, they work in the peak load. In Ukraine, we have turbo detenter more than 15 years, for example, in our infrastructure. If we talk about ORC system or gas turbines, they might work from 5 atmosphere, which is enough pressure to start the low capacity units. But the point is that they can't work 24 hours per day. They can work only in exact so-called balancing mode. And in that case, they can't work to close internal consumption of, for example, compressor station as an object, because in this case, we need to find the right legal issue how these units might work in the future, because all European TSO and DSO companies might face the situation when the gas consumption will be reduced. There will be lack of infrastructure, and in this situation, we will need just to take a look once again on the tariff structure, and we will be before the decision to increase the tariff or to find another business model how to use the infrastructure. That's the point. So it's more about the licenses, but very important. And using the opportunity, if there will be potential and there will be any proposition regarding any soft to work in the balance mode for consumers, for prosumers, any types of other infrastructure users, consumers, that will be very efficient, because in electricity grid, DSOs so-called, it's now one of the biggest step forward. Thank you.
Thank you, Mikola, for update. Actually, I mean, we know that that Ukraine is very much advanced in many things, but then also in using efficiency and other measures in the network. And thank you for raising the question, because this year actually is the year when many things will be decided between DSO, gas DSOs and electricity DSOs, and all these solutions actually proposed with the new directive and new regulation, and even changes which will come, I believe, in network codes and so on. So we don't have answer on all questions, especially not on these policy and regulatory ones, but this is all connected. It's connected to know what technology actually can be applied and what solutions would be needed, and how this all fits in the requirements of upcoming regulation. But I heard, Emanuele.
I thank you, everybody. I have unfortunately to leave in this moment because of very commitment which I cannot postpone. Thank you very much. If you have any other question, please, Andrej can answer on my behalf, and you can also get in touch to me through Andrej. And I wish to have the opportunity in the future to work with you all. Thank you very much indeed.
Thank you, Emanuele.
Thank you, Emanuele.
Presentation will be published, and
we'll pass on the presentation indeed. Thank you very much.
With details, and also webinar is recorded, so everybody can come back later. Actually, if question doesn't appear right now, I mean, related to technical issues. So please, we still
thank you.
Kind of
thank you.
5 minutes. So please go on if you have more questions or suggestions or whatever cross your mind at that point.
If there is no further question, I can add that in some countries, for example, we talk to the DSO and TSO companies and have a look at the entire network, and we can also offer that as a service to make a potential analysis of what would be the potential of recuperating or make use of this energy in terms of electrical output, and what would be the necessary legal framework, right? How this energy could be then legally used within the DSO or TSO company. I think this is a very interesting topic, a very hot topic.
Yeah.
And what we also see in Austria with regards to the situation in Ukraine, we see a decrease in natural gas consumption in some of the areas which in fact, let's say, the stability of the network. And so some stations are redesigned because of the parameters which are changing. And so in this redesigning area, it is also interesting to consider any new technology for the stations, same as heat pumps, right? With heat pumps, we can increase the efficiency of gas preheating, and Actually, I think in Rostock in Germany, some friends of us just finished a project and proved that heat pumps are a great technology to preheat gas in gas reduction stations.
Thank you, Andrej, for additional example. Actually, what I wanted to ask, I mean, you and Emanuele, but if you look at the what is already in place and implemented from that technology and that equipment, so is it more on transmission network or more on distribution network? Or somehow on city gates and that kind of stations and so on?
It's a very good question. Thank you, Karina. So what we see basically is that more DSO companies are looking into this technology because they have several stages of gas reduction. And in the gas transportation system, we see that the gas TSOs, they try to keep the pressure quite stable, as pressure is energy. And I see that, for example, quite some TSO changed gas-fired compressors and turbines to electrical driven, yeah. But in terms of pressure reduction, we see that there is the big potential for DSO companies, and also upstream, we see that there is a lot of pressure on decarbonizing this infrastructure of those systems and try to make them as efficient and green as possible.
Oh, thank you. Thank you. So all this fits together, actually, going with using less energy or saving more energy and then producing less harm for environment, and then moving together in all this energy transition, I mean, system-wise and regulatory-wise. So I think that from our side and from your side, because I don't see a raised hand, that would be all for today. Thank you very much for your interest and for participation. Very much thank to our presenters, to Andrej and to Emanuele. We will publish presentations. We will also publish a recorded webinar. So if you have additional questions, please come back directly to presenters or to the Secretariat. As I said, we started with this webinar exploring actually what is already in place, what exists, what can be implemented, what kind of actually questions this all raising, being type of hydrogen or being what gas DSO can produce, and if this is then electricity production, what with unbundling. We will try to link all this with regulatory framework, of course, but just in purpose, in contrary to all what Secretariat actually is doing, starting from regulatory framework and then coming to technology and to companies. This time we actually wanted to start just from solutions in place and solution to be implemented, not to be bothered immediately with this regulatory framework and then putting article by article on the slides. So we will see if this concept is fine or not, but so far, as I said, the next one can be expected in May. Follow our website to see information, or then anyhow we will also send invitations. So that would be all for today. So have a nice afternoon, sunny greetings from Vienna, and see you in 2 months on that webinar or before on some other energy community events. So thank you very much.
Goodbye.
Bye.
Thank you. Goodbye.
Goodbye.